Good day, everyone. Welcome to this session. Okay. Today we will be discussing a continuation on our probability topic. Specifically, this is about counting or getting the probability of an event. Now, in our previous module or in our previous discussion, we have talked about what is a sample space, what is an event. Now, how do we count the number of outcomes or possible outcomes within a sample space or within an event? Today, we will be using those possible outcomes to get the weight or probability of an event. So another term for weight or another term for probability is the weight of an event. So it is the likelihood of occurrence that an event will result or will happen. No, and the value will be real numbers from 0 to 1. When we say real numbers, these are numbers like which includes decimal numbers. Now, if you can recall the hierarchy of numbers, we have natural numbers, whole numbers, integers, rational numbers, irrational numbers, and those are under real numbers. So we can have 0, 0.001, 0.9999, or 1. So these are the possible weights or probability of an event. So it ranges from 0 until 1. We have here a definition that a probability of an event, if we would say that the event is denoted by A, the probability of event A is the sum of the weights of all its sample points in that event A. So say for example, if um, my event is or my sample space is tossing a coin, okay? We know that the number of elements or the number of possible outcomes when tossing a coin is only two. Now it can be head or a tail. Now suppose we'll have an event A. Okay, we'll have an event A whose outcome is a tail, and another event B whose outcome is head. So we now have two events inside our sample space. Now we only have the number of possible outcomes in event A is 1. The number of possible outcomes no, in B is only 1, which is head only. Okay, now if we want to get the, say for example, the weight of event A, so that is the sum of the weights of all sample points in event A. So since we only have one outcome, no possible outcome for event A, so that's 1. Okay, that's 1 out of 2. No, all in all, our sample space has 2 possible outcomes. Okay, now the sample space or the probability of that event again will range from 0 until 1. And the probability of an empty event or a null set or okay, a null event is 0, and the probability of that sample space is 1. Okay, how do we get that probability that's in between 1 and 0? So that's, for example, A. So A has a 1 probability out of 2, which means if we want to get the probability of event A, that is 1 out of 2 or 0.5. 1 divided by 2 is 0.5. Furthermore, if there are multiple events, so for example here, A and B, okay, the union of these events, the probability of their union is just equal to the summation of their probability. So if I want to get the probability of getting a head and a tail, so that's 1/2 plus the probability of event B, which is also 1/2, and that is equal to 2 over 2 or 1. Okay, that's equal to 1 because since A and B are all, um, we only have two possible outcomes, no, for tossing a coin, no, or flipping a coin. So that's only head and tail. No, the union of A and B is equivalent to the whole sample space. That's why we get 1. However, there are some instances wherein, say for example, three possible outcomes. No, if A, so which means uh, there are three possible outcomes within the sample space, and we have three events, each of which has um, one possible outcome. Let's just say that each of which has one possible outcome. No? And if we want to get the probability of the union of, say, A and B, so that would be not equal to 1, but rather 1 out of 3 plus 1 out of 3. No, since the weight of A is 1, the weight of B is 1, the weight of C is 1 out of 3 possible outcomes. So that's 2 over 3. Or approximately that's 0.6667. So that's how we get the probability of an event. So let's take this example. The coin is tossed twice. What is the probability that at least one head occurs? Remember that a coin has only two possible outcomes. Now, it can be head and tail. Now, since it is tossed twice, so therefore, the possible outcomes are head. Then the second toss will be head. Then the first is head, the second is tail. Then we have tail, head, and tail, tail. So all in all, there are four possible outcomes in the sample space. However, we are only concerned of those outcomes of the event wherein at least one head occur. So we have which outcomes here has at least one head. We have head, 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 tail, and tail, head. So if we would say A be the event that at least one head occurs, so that's HH, head, 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 tail, and tail, head. So what do you think is the probability of getting at least one head? Okay, then, so how many of these possible outcomes are? How many are these? We have head, 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 tail, and tail, head. We have three. So that's 3 out of 4. No, and each one of which has, so it has 1, 4. So its weight is 1 out of 4, 1 out of 4, 1 of 4, 1 of 4. Since we are only concerned with this one, which that's within event A, so we will only add the weights of the 3. And that's 3 over 4, okay, or 0.75, okay? So another way here is writing there are three possible outcomes. So that's N of A. So getting PA, we'll get the possible outcomes of the event divided by the possible outcomes of or within the sample space. That is 3 over 4. Actually, we have a definition later on for this one. So now, to get the decimal value, the real value of that fraction, so that rational number, that's 0.75. Another way of expressing or getting the possible outcomes and the probability of the event is using a tree diagram. We know that in tossing a die, there are two possible outcomes. Now we have head or tail. If in my first toss, the outcome is head, therefore, in my second toss, there are also two possible outcomes. That's head or tail. Same with when the first outcome is tail. Now here, if you take a look at this, there are only two possible outcomes, which means each of the possible outcomes is a weight of 1 out of 2. Same here. We have 1 out of 2, 1 half, 1 half, and 1 half. So the total or the possible sample points rather are head tail, tail head, and tail tail. Getting an head has 1 half weight. No, the probability is zero point 0.5 or 1 half. And also, getting another head is 1 half. So if you multiply these two, we'll get 1/4. And same with this, we have 1/4. And we also have 1/4. This one also has 1/4 weight. Since we are only concerned with getting at least 3 ahead, so we'll just add this 3. So therefore, we'll get 3/4. Okay. I have shown you different methods in getting the probability of an event. Let's try another example. A die is loaded in such a way that an even number is twice as likely to occur as an odd number. If E is an event, then a number less than 4 occurs on a single toss of a die. Find the probability of E. Now, take note that an even number is twice as likely to occur, so which means it has um, twice the weight of odd numbers. So we have here, supposedly we will write this one. Now you have S is equal to, kindly ignore the other commas there. So we have 1, 2, 3, 4, 5, and 6. It's just okay that we will write the set here, the sample space in this form. But you have to take note that based on this problem, even number is twice as likely to occur as an odd number. So therefore, we can also write this in this manner so that we can count the possible outcomes of the sample space. Now we have 1, 2, 2, 3, 4, 4, 5, 6, 6. Therefore, our sample space, the total weight on the total sample points now of our sample space is 9. And each of these has 1 over 9. However, if we will only write this one, so which means that the weight of 1 is 1 over 9. The weight of 2, since 2 has uh, twice like as likely to occur than 1, so it is 2 over 9. For number 3, it's an odd number, so that's 1 over 9. For number 4, that's 2 over 9. 5 has 1 over 9 weight. And 6 would be 2 over 9. E here is the event wherein the number is less than 4. So what are the numbers less than 4? We have 1, 2, and 3. So therefore, we'll have to add the weights of 1, 2, and 3. And that's 1 over 9 plus 1 over 9 plus 1 over 9, a total of 4 over 9. And the real value or this rational number expressed in decimal points or decimal value is 0.0444. So I would recommend that you express it in 10,000s, no, in 4 decimal places. So 4 over 9 is approximately 0.4444. Next, how about this one? In number 2, let A be the event that an even number turns up, and B be the event that number is divisible by 3 occurs. So going back to our set, again, we can write this as a set which has 1, 2, 3, 4, 5, 6 elements or sample points. But we know that 1 has 1 over 9 weight, 2 has 2 over 9 weight, and so on. Then, what are or how do we determine the possible outcomes of event A? Based on the problem, event A are those that an even number will occur, no, or will turns an even number turns up. And event B are those numbers divisible by 3. So here the even numbers are 3, 2, 4, and 6. And the numbers divisible by 3 are 3 and 6. So therefore, A has 2, 4, 6, B has 3, 6. Then the union of the two is 2, 3, 4, 6, and the intersection is 6, since 6 is the common outcome for A and B. So getting their weights, 2 has 2 over 9, 3 has 1 over 9, 4 has 2 over 9, 6 has 2 over 9. So same here, 6 has 2 over 9. So adding the weights, you have um, that's 7 over 9, or 0.778 for the union of the two events, and 0.222 for only getting 6. So that's how we get the probability of an event. Now, given the elements or the possible outcomes within the events and the sample space. So again, this is a definition on how do we get the probability of the event given the sample points. Okay. So we have n will be the number of possible outcomes within the sample space. So if you would recall earlier that I denote the number of outcomes of S. So here we will use uppercase N. However, when we want to know the number of possible outcomes of certain events, okay, if these are events, then we will denote a lowercase n. Let's have this example. Okay, a statistics class for engineers consists of 25 industrial, 10 mechanical, 10 electrical, and 8 civil engineering students. If a person is randomly selected by the instructor to answer a question, find the probability that the student chosen is an industrial engineering major and a civil engineering or an electrical engineering major. Now let's start with the total number first. We have 25 plus 10 plus 10 plus 8, that's 53. So our n is 53. Now let's separate them first. 25 for industrial, so we will denote event A, that an industrial engineering student will be selected. Event B, that a mechanical engineering student will be selected. And event C for electrical, and D for a civil engineering student that will be selected by the teacher. Now, in our first problem, or in our first case, we are asked about the probability of the student chosen is an industrial engineering major or industrial engineering student. Here, event A is our uh, industrial engineering student. So there are 25 among 53. So if you recall the definition there, that the probability of an event is equal to the number of sample points of that event divided by the total number of sample points, okay, or the number of sample points within the sample space. So therefore, A, no, the probability of getting of selecting an industrial engineering student is 25 over 53, or approximately 0.4717. Next, we have a civil engineering or an electrical engineering. Now take note of this, since we are uh, shown that based on the problem, it's or, so it's either civil or electrical. So the what operation are we going to use if it's an or? The answer to this one is we will use union. So therefore, we have civil engineering is set or event D. Electrical engineering students is event C. So that's the union of C and D. Now, We have 10 for electrical and 8 for civil engineering students, a total of 18 out of 53 students. And that's approximately 0.3396. Next, in a poker hand consisting of 5 cards, find the probability of holding 2 aces and 3 jacks. Here, for this problem, this is now quite a complicated or challenging problem. Why? If you recall in our previous discussion, a deck of playing cards consists of 52 different cards. Now we have 52 different cards ranging from ace to king, and per set we have different signs. Now we have a heart from ace to king, diamond from ace to king. Then we also have a spade, okay, and a 3-leaf clover. So, let's just say that it's a clover. Okay, we have 13 hearts, 13 diamonds, 13 spades, and 13 clover. Now, how many ways or how many sample points can we get from these 52 cards? We'll only be getting 5. No, 5 cards out from these 52 cards. What do you think are we going to use in order to get the possible outcomes or sample points of getting 5 cards in or in 52 uh, cards, no, in a set of playing cards? The answer is we'll have to use the combination. Okay, but before that, let's consider first the events here. So what are the events in the problem? Our sample space is the 52 deck of playing cards, no? But we have these events. The first event is we will get 5 cards. Okay, it doesn't matter if it has aces or jacks, but we'll get 5 cards. We'll denote this as event A. Next is we'll get 2 aces. Let's say event B. Next is we'll get 3 jacks. So that's C. Why do we consider or do we need to separate first these events? That is because we have in this 52 set of playing cards, we have 4 aces. Then we'll only be selecting two out of these 4. Same with the jacks. We'll only be selecting 3 out of the 4 jacks. No, yeah. Okay, we'll only be getting 3 out of these 4. And also, we'll need to have an event that we have now 2 aces and 3 jacks, and we will denote D for that one. So these are our events. 5 cards, and that's denoted by A, uppercase A. Event B is holding 2 aces. Event C is holding 3 jacks, and event D is holding both 2 aces and 3 jacks. So as I have told you earlier, we have to get first how many possible outcomes in getting 5 cards or in holding 5 cards among these 52 playing cards. So we will use combination. Okay, that's 52 getting 5 out of 52. And if you recall, the simplest way of expressing a combination is using the variable c. So that's 52c 52c5. So since we're only be getting 5, and kindly recall how do we calculate the combination? Okay, recall how combination is calculated, and based on that, we'll have 2,598, 2,598,960 possible combinations. Remember that in combination, we don't care about the sequence or the arrangement of the elements or the sample points, the elements rather, no, or of the objects. We're only concerned about the occurrence. Okay, so the sequence is not a concern in the combination. No, we only if we are if we want to know of if we consider the arrangement or the sequence of the objects, then we will use probability, permutation rather instead. No, we will use permutation instead. So since here we don't care about the arrangement of the objects, so we will use combination. Next, so these are the possible outcomes now when selecting 5 cards out of the 52 playing cards. Next, how many possible outcomes in getting 2 aces out of 4? And that is 6. Now there are 6 possible outcomes in getting 2 aces out of the 4 aces in the 52 playing cards. In getting 3 jacks, we have 4 possible outcomes. And therefore, in getting uh, 2 aces and 3 jacks, and we will have to multiply these two. So the number of possible outcomes of getting 2 jacks and 2 aces rather and 3 jacks is 6 times 4, and that's 24. So that's 24. Okay, again. Oh, what's happening? That's 24 out of 2,598,000. Okay, 2,598,960. If we will convert this into its decimal form, that is, okay, what's happening? Okay, 0.00000923 and 4. So it's a very, very small value. Getting 2 aces and 3 jacks in a 52 playing cards is has a probability of 0.00000923. Okay, so I hope this will be the end of our discussion, and I hope you have learned how to get the probability of an event. And in getting the probability of an event, we must know how to get the number of sample points in an event. So you have to remember that one. For your activity, I want you to answer this question. Okay. Okay. In your engage part or engage section in this module, answer this one. A box contains 100 envelopes, 15 contain 200, 40 contains 100 pesos, 25 contains 50 pesos, and 20 envelopes contain 20 pesos. So find the probability that the first envelope purchase contains 100 pesos. Okay. And find the probability that the first envelope purchase contains 20 pesos but less than 200 pesos. You have here the answers. Now all you need to do is to provide the solution to this question. That would be all. Okay, that would be all, and thank you very much for joining this session. See you on the next topic.